Jake, you ready?
Yep.
Okay.
I am Jacob Martin. I am a first semester student of the Energy Systems program here at the College of Eastern Idaho. And I'm going to demonstrate one of the motor control boxes that we have been building all semester. So I will start by first demonstrating the operation of this box. Probably the most important thing with working with electrical systems is safety. So whenever we are working inside this motor control box, we are always sure to lock out and tag out. Normally with lockout tagout, you would write your name on it and you would take this key so everybody knows who is in charge of this machine, essentially. And so, first things first, we remove the lockout tagout, and we are always sure to face away from the machine as we operate it, or as we energize it, and we say power on to alert everybody else that we are energizing this system. So power on. And so from here, we are activating our variable frequency drive, which is set to 60 Hertz. And as that powers up, we then release the emergency stop, and that energizes the full circuit. And we have a forward motor control where there's a mechanism that will latch it closed so that way the motor continues to run. And while that is latched, we cannot activate the reverse of this until we stop it. And then this is our the reverse motion of our motor, and same thing as the forward, it is completely locked out. And another feature we have on this box is a jog. So when the jog is active, we can start the motor and it disables the locking mechanism of it, so we can run our forward and immediately stops once we release the button. Same thing with our reverse, and it does, same thing, it locks out the other option for running the motor. And with this motor control box, we have multiple different ways to cut the power to it. We can either hit the emergency stop in case of an emergency. We can hit this stop, as I've already demonstrated. But we also have what's called a limit switch, which is connected to a timing relay. That as we activate this limit switch, it starts a timer as long as it stays active, and it will. So now we do the limit switch, and it will start the timer, which will eventually cut off all power to the motor. And it works the same way with the reverse. Another way is we have a proximity switch under here, which will activate when it comes into contact with metal, and it will disable the motor. And so when we're done operating this box, we hit the E-stop and we power down the variable frequency drive. And because of the capacitors in here that will still hold a charge, we wait a minute before we get into the machine. And so we turn it off, cut all power to it, and let those capacitors discharge. And then once we're ready to open up the machine, we remember to always lock out the machine. And then it is safe to get inside. So inside our motor control box, this is the VFD that I mentioned. And as the power comes in here, it is then sent to a transformer, which steps down the voltage, which leads to our control circuit, and then also to our load circuit. So these are the motor control relays, where this one is our forward, this one is our reverse. And down here we have another transformer, that this transformer operates the cooling fan, as well as the timing relay and our other control relay. Let's see. What else do I want to talk about? Oh, okay. So, as the power initially comes in one phase, and our variable frequency drive splits it into three-phase power. which is what is required to operate our motor. And the transformer, as well as stepping down, also converts it back into one phase, which is what runs our entire control circuit. That's about it.